Welcome back to JVM Internals Crashcasts. I'm your host Sheila, and today we're continuing our journey through the fascinating world of JVM Internals. We're currently in Season 1, JVM Novice, exploring the fundamentals of the Java virtual machine. In our previous episodes, we discussed the stack versus heap and object lifecycle. Now we're diving into a crucial aspect of memory management: garbage collection. Joining me as always is our JVM expert, Victor. Victor, are you ready to take out the trash?
Absolutely, Sheila. I'm excited to dig into the world of garbage collection. It's a topic that's often misunderstood, but is crucial for efficient Java programming.
Great. Before we start, I have a quiz question for our listeners. What do you think happens if garbage collection is never performed in a long-running Java application?
Oh, that's an intriguing question, Sheila. It really gets to the heart of why garbage collection is so important. I'm curious to see what our listeners think. Without giving away the answer, I can say that it touches on some fundamental aspects of memory management in Java.
Excellent. We'll reveal the answer at the end of the episode. Now, let's start with the basics. Victor, can you explain what garbage collection is and why it's necessary?
Of course, Sheila. Garbage collection is an automatic memory management feature in Java. It's essentially a process that identifies and removes objects that are no longer needed by the program. This is necessary because in Java, unlike languages like C or C++, developers don't manually allocate and deallocate memory. The garbage collector takes care of this, which helps prevent memory leaks and makes programming easier and safer.
That's interesting. So it's like having a cleaning service for your program's memory. But how does it know which objects are no longer needed?
Great analogy, Sheila. The garbage collector determines which objects are no longer needed through a process called reachability analysis. Essentially, it starts from what we call root objects. These are objects that are directly accessible to your program, like static variables or local variables in the currently executing methods. It then follows all the references from these roots and marks all the objects it can reach. Any objects that aren't marked after this process are considered garbage and can be collected.
That makes sense. So it's like tracing a path through all the objects your program can actually use, and anything left over is garbage. Can you tell us a bit more about how the actual collection process works?
Certainly. The most basic garbage collection algorithm is called mark and sweep. As we just discussed, it first marks all reachable objects. Then, in the sweep phase, it goes through the heap and frees the memory occupied by unmarked objects. However, this is just one type of garbage collection algorithm. Modern JVMs have more sophisticated collectors that aim to minimize pause times and maximize throughput. Let's explore some of these in more detail.
I've heard terms like stop the world and concurrent collection. Can you explain what these mean?
Good question, Sheila. Stop the world refers to when the garbage collector suspends the application threads to perform collection. This ensures that the state of objects doesn't change during collection, but it can cause noticeable pauses in the application. Concurrent collection, on the other hand, allows the application to continue running while garbage collection is performed, which can reduce pause times. However, it's more complex to implement and can have some overhead.
That's fascinating. It seems like there's a trade-off between application responsiveness and efficient memory management. Are there different types of garbage collectors to handle different scenarios?
Absolutely. Java actually provides several garbage collectors, each with its own strengths. For example, there's the serial collector for single-threaded environments, the parallel collector for multi-threaded applications that can tolerate some pauses, and the concurrent mark sweep, CMS, and garbage first, G1 collectors for applications that require low pause times. The choice of collector can significantly impact your application's performance.
Wow, I had no idea there were so many options. It sounds like choosing the right garbage collector is an important consideration for Java developers. Are there any challenges or potential pitfalls with garbage collection that developers should be aware of?
Definitely, Sheila. While garbage collection is generally a huge benefit, it's not a silver bullet. One common misconception is that Java programs can't have memory leaks because of garbage collection. In reality, Memory leaks can still occur if objects that are no longer needed are still reachable. For instance, if you add objects to a collection and forget to remove them when they're no longer needed, they'll never be garbage collected.
That's a great point, Victor. It seems like developers still need to be mindful of their object life cycles, even with garbage collection. Do you have any tips for our listeners on working effectively with garbage collection?
Absolutely. Here are a few key tips. 1. Be mindful of object creation and try to reuse objects when possible. 2. Use profiling tools to understand your application's memory usage patterns. 3. Consider using weak references for caching scenarios to allow unused objects to be collected. 4. If you're dealing with large-scale applications, don't be afraid to tune the garbage collector settings to suit your specific needs. And here's a fun fact. The term garbage collection was actually coined by John McCarthy in 1959 when describing memory management in Lisp. It's been a fundamental concept in programming languages for over 60 years.
Those are great tips, Victor, and that's a fascinating bit of history. Now let's get back to our quiz question. What happens if garbage collection is never performed in a long-running Java application?
Well, Sheila, if garbage collection is never performed, the application will eventually run out of memory. As new objects are created and old ones become unreachable, the heap will fill up with garbage objects that can't be used but are still taking up space. Eventually, when the application tries to create a new object and there's no more free memory, it will throw an out-of-memory error. This is why garbage collection is so crucial for long-running Java applications.
Thank you, Victor. That really underscores the importance of garbage collection. To summarize what we've learned today. 1. Garbage collection is an automatic memory management feature in Java. 2. It identifies and removes objects that are no longer needed by the program. 3. There are different types of garbage collectors, each with their own strengths and use cases. 4. While garbage collection helps prevent memory leaks, it's not foolproof, and developers still need to be mindful of object life cycles. 5. Proper understanding and tuning of garbage collection can significantly impact application performance. In our next episode, we'll be moving on to Level 2, JVM Adept, where we'll start exploring the JVM memory model in more detail. Don't forget to subscribe to JVM Internals Crashcasts and leave us a rating if you're enjoying the series. Until next time, happy coding.